Our planet, this beautiful blue sphere spinning silently in the vastness of space, has a story of almost unimaginable length. It is a tale of fire and ice, of cataclysm and creation, of life's extraordinary resilience and endless invention. To understand our world today, and indeed our own place within it, we must travel back in time. Not just hundreds or thousands of years but billions. We must journey to a time when the Earth was a place utterly alien to us, a world still being forged. This epic history is written in the rocks beneath our feet, in the fossils of creatures long vanished, and in the very air we breathe. If we were to compress Earth's entire 4.5 billion year history into a single calendar year, the first multi-celled life would not appear until September. The dinosaurs would roam from the middle of December until the day after Christmas. The whole of recorded human history would flash by in the final minute before midnight on New Year's Eve. It is a humbling perspective, one that reminds us that we are but the latest arrivals in an ancient ongoing drama. Each chapter of this story, each great geological era, holds wonders that shaped the world we know. So let us begin this grand tour. We will witness the planet's violent birth, a glowing ball of molten rock. We will see the first tentative sparks of life emerge in primordial oceans, simple cells that would go on to change the entire atmosphere of our world. We will explore ancient seas teeming with strange and wonderful creatures, watch as the first green shoots colonize the barren land, and stand in the shadows of the mighty dinosaurs. This is not merely a story of the past, it is the story of our home, a chronicle of the immense forces and delicate balances that have allowed life to flourish here. Our journey through time is one of discovery. With every layer of rock we peel back, we find new characters and new plot twists in Earth's grand narrative. This history is not a static collection of facts, it is a dynamic living saga. It shows us how change, often on a colossal scale, is the one constant in our planet's existence. By looking back, we can perhaps gain the wisdom to look forward and appreciate the precious and perhaps precarious nature of our present moment. Our story begins over 4.5 billion years ago. This was the Hadean Eon, a name derived from Hades, the underworld. The young Earth was not the tranquil blue marble we know today. It was a hellish sphere of molten rock, a glowing orb constantly bombarded by meteors and asteroids streaking in, comets flashing by. There were no oceans, no continents, not even a stable crust. A thick, toxic atmosphere choked the planet. During this inferno, a momentous event occurred. A Mars-sized object collided with our planet. Debris was blasted into orbit. That debris would coalesce to form the moon. Gradually, over hundreds of millions of years, bombardment slowed. The planet's surface began to cool. A skin formed on cooling lava. Water vapor condensed. It rained for millions of years. A planet-wide deluge filled the basins. The first primordial oceans formed. Those early seas were murky, iron-rich green. Into that chemical soup, under a faint young sun, the Archean Eon was about to begin. Life was about to begin its long journey. No one knows for certain how the first spark ignited, perhaps at deep-sea hydrothermal vents. Whatever the origin, the first life was simple. Single-celled organisms, prokaryotes like bacteria. For over 1 billion years these microbes ruled the Earth. One group, cyanobacteria, did something incredible. They developed photosynthesis. They harnessed sunlight to make food. In the process they released a waste product. That waste product was oxygen. The great oxidation event followed, toxic to much of life then, but it created the air all complex life, including us, would one day need to breathe. Following the great work of the cyanobacteria, we enter the Proterozoic Eon, a period stretching from 2.5 billion to about 541 million years ago. For much of this eon, life remained microscopic, but behind the scenes, a critical evolutionary leap was taking place. Some single-celled organisms evolved a far more complex internal structure, developing a nucleus. These were the first eukaryotes, the ancestors of all plants, fungi, animals, including ourselves. The world these early eukaryotes inhabited was still starkly different from our own. Continents were forming, breaking apart, colliding, creating supercontinents like Rodinia. But the land itself remained almost entirely barren, a silent, empty world of rock and dust scoured by wind and rain. All the action was still in the oceans. And then, something truly remarkable happened. Some of these complex single cells began to cooperate and clump together, eventually forming the very first multicellular organisms. Life was beginning to experiment with teamwork. Towards the end of the Proterozoic, the planet was plunged into snowball Earth. For millions of years the planet may have been covered in ice. How life survived this deep freeze is a testament to its tenacity. When the ice finally retreated, it seems to have triggered a burst of evolutionary innovation. In rocks from the very end of this eon, we find the first fossil evidence of large, complex life. These are the mysterious Ediacaran biota. They were strange, soft-bodied creatures unlike anything alive today. Some looked like quilted air mattresses, others like fronds, or simple disc-shaped blobs. They had no apparent heads, mouths, or guts. For tens of millions of years they dominated the quiet, dimly lit seas. Then they vanished, leaving room for the next cast of characters. Our journey now brings us to the Paleozoic Era, which began 541 million years ago. The start of this era is marked by one of the most spectacular evolutionary events, the Cambrian explosion. Over a geologically brief period, the ocean suddenly became filled with an astonishing diversity of complex animal life. It was as if a biological Big Bang had occurred. Almost all the major animal body plans, or phyla, that exist today appeared. The stars of this new world were creatures that seem both alien and faintly familiar. One of the most famous inhabitants was the trilobite. These armored arthropods, distant relatives of modern insects and crustaceans, scuttled across the seafloor in their thousands. Alongside them swam bizarre predators like Anomalocaris, a large shrimp-like creature with formidable grasping claws and a circular mouth full of sharp plates. The Cambrian seas were a dynamic and dangerous place, a world of newly evolved predators and prey engaged in an ever-escalating evolutionary arms race. As the Paleozoic progressed, life continued to diversify in the oceans. In the Ordovician period, in the Silurian period, these were our most distant boned ancestors, filter feeding from the seabed. Coral reefs appeared for the first time, creating vast and complex habitats. Sponges, brachiopods, nautiloids, relatives of modern squid with straight or coiled shells. The seas teemed with life, giant sea scorpions, some growing longer than a human, to the first fish that evolved jaws, a revolutionary adaptation that would change the face of predation forever. During the Ordovician, a nautiloid called Camarasaurus could grow a straight cone-shaped shell up to 9 meters long. Imagine a squid-like animal inhabiting a shell the length of a school bus, jetting through the ancient oceans. It was one of the largest predators on the planet at the time, a true leviathan of the Paleozoic seas, showing that life was capable of evolving impressive forms long before the dinosaurs. While the oceans were a theater of vibrant evolution, the land remained a desolate, empty frontier for the first half of the Paleozoic era. It was a world of bare rock, sand, and dust, baked by a harsh, unfiltered sun, but life was poised to make its next great leap. The first pioneers were humble plants, likely related to modern mosses and liverworts, which began to colonize the damp edges of rivers and lakes during the Ordovician and Silurian periods. They clung to the rocks, forming a thin green carpet. This simple act of colonization was revolutionary. Their roots broke down rock, creating the first true soil. Following the plants were the first animals to venture ashore. These were not mighty beasts, but small arthropods, scorpions, millipedes, and spider-like arachnids, already equipped with a supportive exoskeleton and jointed legs that were pre-adapted for life out of water. This great land invasion happened during the Devonian period, often called the Age of Fishes, but it was just as much the age of the first forests. The succeeding Carboniferous period saw the conquest of land reach its zenith. Vast, swampy forests covered much of the world's tropical land masses, but these were not forests as we know them. They were dominated by giant club mosses, horsetails that towered over 30 meters high. The air was thick with moisture and incredibly rich in oxygen, perhaps reaching levels of 35%. This oxygen-rich atmosphere allowed arthropods to grow to terrifying sizes. Imagine dragonflies like Meganeura, with wingspans the size of a modern seagull. Picture millipedes, such as Arthropleura, stretching over 2 meters long, as large as a small alligator. It was a unique window in Earth's history when insects, not vertebrates, were the giants of the land. The Paleozoic era ended with the most devastating mass extinction event in Earth's history, the Permian-Triassic extinction, which wiped out over 90% of all marine species. But from these ashes, a new world would rise. We now enter the Mesozoic Era, the age of reptiles. In the Triassic period, the first of the Mesozoic's 3 acts, the survivors began to repopulate a dry, arid world. Early dinosaurs were mostly small, bipedal creatures. living in the shadow of other large reptiles like the crocodile-like phytosaurs. It was in the following Jurassic period that the dinosaurs truly came into their own. This was the age of giants. The climate became warmer and wetter, and lush forests of conifers, cycads, and ferns spread across the continents. This abundance of plant life fueled the evolution of the colossal sauropods, the largest land animals ever to have lived. Creatures like Brachiosaurus, with its long neck held high, and the immensely long Diplodocus, browsed on the treetops. Their sheer scale is difficult to comprehend. They were walking ecosystems, their footsteps shaking the Jurassic ground. Meanwhile, a different kind of dinosaur was evolving to prey on these gentle giants. The Jurassic saw the rise of formidable carnivorous theropods, such as the fearsome Allosaurus. But the dinosaurs did not have the world to themselves. In the oceans, great marine reptiles like the dolphin-shaped ichthyosaurs and the long-necked plesiosaurs ruled the waves. And in the skies, the pterosaurs, flying reptiles with leathery wings, soared and hunted. A truly surprising fact from the Mesozoic is that not all dinosaurs were giants. While we are captivated by Tyrannosaurus and Triceratops, a huge number of dinosaur species were much smaller. For instance, Compsognathus was a theropod dinosaur no bigger than a chicken. Microraptor, a small four-winged dinosaur from the Cretaceous period, was about the size of a crow and may have glided from tree to tree. These smaller species reveal a much richer dinosaur world, scurrying through the undergrowth of a world dominated by their larger relatives. Narrator Avo. As we move from the Jurassic into the final chapter of the Mesozoic, the Cretaceous period. Narrator Vo. The world continued to change. Pangaea was breaking apart. Narrator Vo. The Atlantic Ocean widened. It separated the Americas from Africa and Europe. Narrator Vio. New coastlines and shallow inland seas formed, altering climate and ocean currents. This fueled evolutionary innovation. Narrator Vio. Flowering plants, angiosperms, appeared. Narrator Vio. They transformed the landscape. Narrator Vo. Flowers evolved to attract insects and other animals to carry pollen. Narrator Vio. That coevolution exploded plant and insect diversity. Narrator Vio. Trees like magnolias. Narrator Vo. Figs. Narrator Vio. Sycamores emerged. Narrator Vio. New vegetation changed herbivore diets, favoring horned ceratopsians like Triceratops. Narrator Vio. And duck-billed hadrosaurs with complex teeth. Narrator Vo. The Cretaceous was the dinosaur's pinnacle. Narrator Vio. Tyrannosaurus rex emerged. Narrator Vo. Massive skull, bone-crushing jaws, tiny two-fingered arms. It hunted late Cretaceous North America. Narrator Vio. It lived alongside Ankylosaurus and feathered, pack-hunting dromaeosaurs. Raptors. Narrator Vio. Life was abundant and finely tuned over 150 million years. Narrator Vio. Then, 66 million years ago, disaster struck. Narrator Vo. A 10-kilometer wide rock hit near the Yucatan Peninsula. Narrator Vo. Energy released equaled billions of atomic bombs. Narrator Vo. It triggered global earthquakes. Narrator Vo. It unleashed continent-spanning tsunamis. Narrator Vo. A superheated plume of debris shot into the sky and rained down, broiling the surface. Narrator Vo. A long, dark impact winter followed, killing the plants and ending the dinosaurs and the Mesozoic Era. The cataclysm that ended the Mesozoic Era wiped out the non-avian dinosaurs and around 75% of all species on Earth. This extinction event created a huge ecological vacuum. We enter the Cenozoic Era, the age of mammals. In the shadow of the dinosaurs, small shrew-like mammals had been scurrying for millions of years. With their giant reptilian competitors gone, these survivors found a world of opportunity. In the first few million years of the Cenozoic, mammals underwent a spectacular adaptive radiation, rapidly diversifying to fill the empty niches. Some took to the trees, evolving into the first primates. Others became herbivores, growing larger to feed on the recovering vegetation. There were huge, flightless predatory birds like Gastornis. As the Cenozoic progressed, the continents continued to drift and the climate began a long, slow cooling trend. This led to the expansion of new habitats, such as vast grasslands. This drove the evolution of grazing animals like horses. Horses evolved from small, forest-dwelling creatures into the large, hoofed animals we know today. In the oceans, some mammals returned to the water, evolving into the first whales, showing that the path of evolution can sometimes lead back to the sea. The latter part of the Cenozoic is defined by a series of ice ages. Great glacial sheets advanced and retreated across the northern continents. This was the world of the megafauna: woolly mammoths, saber-toothed cats, giant ground sloths, woolly rhinoceroses. The Paraceratherium, a hornless rhinoceros that lived earlier in the Cenozoic, was the largest land mammal of all time. It stood about 5 meters tall and weighed up to 20 tons. Out of all the evolutionary experimentation of the Cenozoic, one group of primates in the forests and savannas of Africa embarked on a unique path. They evolved to walk upright on 2 legs, freeing their hands to make tools. Their brains began to grow in size and complexity. It culminated in Homo sapiens in Africa around 300,000 years ago. For most of our existence, we were hunter-gatherers. Our numbers were small, our impact was minor. Around 12,000 years ago, the Ice Age ended. We learned to cultivate plants, domesticated animals. The last few centuries, a blink in geological time, things accelerated. Our population exploded to over 8 billion people. A satellite view shows the globe lit by our cities at night. We now change the planet on a geological scale. As the first species to understand deep history, we have a unique responsibility. The decisions we make now will determine the future for countless species and will write the next chapter in Earth's extraordinary story.